Hey kids, this is Mr. Cozy, and today we are going to look at the follow-up to video 53. Because 53 kind of introduces the concept of a logarithm, and you see a lot of ideas. The big thing that we're going to be doing today in class is solving logarithms. So I just want to take a second and walk you through some simple logarithms and how you can solve them. The goal of this is that you're able to look at a logarithm like this and just kind of be able to know what the answer is. Until you can get there, we're going to use this conversion. For a long time, our default strategy is going to be taking a logarithm and rewriting it as an exponential, because you guys have some experience with solving exponential equations now. So if I convert a log to an exponential, you should have some tools that you can use to solve it. For example, log with 3 as a base of 81. So just so that I have a variable to work with, I'm just going to say this equals y, just so that when I do the conversion, I have something to put in that position. So my answer is y, whatever that is. Here's my base. Oops. Shoot. Try that again. Yes. Here's my base. Here's what I'm taking the log of. And here's my answer. And if I follow this handy-dandy color-coded guide, the base of the log becomes the base of the exponent. The answer to the log is my exponent. And the thing that I'm taking the log of is the thing that I want to hit. So I want to raise 3 to a power and get 81. And maybe I know this, maybe I don't. I really can't rewrite 3 to be any smaller, so if I don't know what the answer is, I'm just going to take my calculator and multiply it by 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. I multiplied 3 with itself 4 times, so my answer is 4. The log base 3 of 81 is 4. Hit pause and take a stab at this one. Log with 5 as a base of 25. Let me get you started. Let's let your answer be y, and I'll even color code it for you. There's the base of the log. There's the answer to my logarithm. Oops, I accidentally deleted part of the y. Let's try that again. There's the answer to my logarithm, and there's the thing that I'm trying to take the log of. So take a second and try to solve this. So we have 5 is my base, y is my exponent, and I want to hit 25. And hopefully you know that 25 is 5 to the second power. Okay? Now, sometimes logs will work out very cleanly like this. Sometimes you might have to do a little solving. Let's take a look at log base 9 of 27. And actually, I'm going to hit pause and just move these over. There we go. Now I have a little more room to work. So once again, base of give me the magnifier. There we go. Base of my logarithm. This is what I'm taking the log of. And I want to equal some number y. That's my answer. That's what I want that to be. So we have 9 to the y power equals 27. Okay, now this is a more detailed exponential that I have to solve. You solve it by getting the bases to be the same. 9 is 3 squared. So this is 3 to the 2y, because the exponents multiply. 27 is 3 to the third. I can then ignore my bases. I get 2y equals 3, divide, divide. I get 3/2. Y is 3/2. Log base 16 of 1/8. Once again, let's color code this. There's my base. There's what I'm trying to hit. And my answer I'm going to call y just so that I have something to write. So I have 16 to the y power equals 1/8. My first step is to get rid of that fraction. So I get 16 to the y power equals 8 to the -1. Flip that fraction. It's kind of a tight 16. There we go. I can rewrite both of these. That's an awful 16. I can't get over how bad this 16 is. There we go. Okay. I've got to rewrite these with the same base. I know that 8 goes into 16, but that doesn't help me because I got to think about powers. 16 is 2 to the 4th power. 8 is 2 to the 3rd power. And remember, when I do those rewrites, I multiply my new exponents with whatever was there already. That's how I got 4y and -3. I can then ignore my bases and solve my exponents. Y is -3/4. So, guys, this is how you straight up solve logarithms. You take the logs, you rewrite them as exponentials, and you solve the exponentials. Now, because this is algebra, I can also put my variable in different positions. So let's say I want to know if I have a 5 as the base of my logarithm, what number will give me 4 as an answer? So there's the base of my log, there's my answer, and there's the number I'm trying to hit. Looking at that conversion again, I get 5 to the 4th power equals x. And the problem kind of falls apart from there. 5 times 5 times 5 times 5 is 625. 625 is x. Over here on this this other log, you know what? Take a second and hit pause and try this. I'll even color code it for you. There's the oof. I'll erase it too. That's helpful. There we go. There's the base of the log. There's the target I'm trying to hit. There's the answer to the logarithm. Take a look at that. Take a look at that. Solve for x. So I have 7 to the 2nd power equals x. X is 49. Okay. So not only can I solve logs straight up, I can do algebra on logs to solve for what I'm taking the log of. I can also, if I have the variable as my base, because this is algebra, I can put a variable anywhere, I can put a number. I could solve this too. I just have to rewrite it as an exponential. So the base of my log is the base of the exponent. The answer is my exponent. X to the 3rd equals 125. Now, the big difference between this and these other problems is this is not an exponent. I rewrote it as an exponential, but my variable isn't in the exponent, which is one of the defining characteristics of an exponential. My variable is actually the base. So I can solve this by just taking a cube root of each side. Cube root of 125 is 5. Okay? So guys, this conversion, log to exponential, exponential to log, is going to be very useful for the assignment today. Okay, I'm going to stop here. Have a great rest of your day. Bye-bye.